Good morning. Welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss interesting things in the technology world, all manner of good trends and products in the technology world. So welcome back if you're a repeat viewer, and welcome if it's your first time seeing Coffee Break. I'm your host, Eric Latfelter. Joining me in the studio today is Aliyah Fahout. Aliyah, welcome back, and can you, as usual, can you give our audience an overview of how they can interact with us during Coffee Break today?
Yeah, absolutely. Thanks, Eric. Well, good morning, everyone. Thank you for joining us today. We are currently live on YouTube, Facebook, and LinkedIn. You can participate in today's episode by leaving your questions and comments in the chat or email us at livestream@microchip.com after the broadcast. Don't forget to follow, like, and subscribe to all our social media platforms. Thank you, and back to you, Eric.
All right, thanks, Aliyah. All right, on to our topic. Interesting topic today, designing your own wireless power solution with reference designs from Microchip. Joining us in the studio today is Product Marketing Manager Vijay Bapu. Vijay, welcome to Coffee Chip, welcome to the studio.
Good to see you.
Yeah.
Good to see you in person.
Yes, very great. We have the whole team here in the studio today. Yeah. So before we dive into some of the details, we're talking about multiple reference designs for a single application area. So can you give us an overview of the landscape of wireless power solutions today?
Yeah, sure, yeah. Like you mentioned, wireless power is a pretty broad segment, if I would say, and we can really segment them based on power levels and technology used for wireless power. On this slide, I'm just showing the different solutions that we have at Microchip. At the leftmost, we have wireless power solutions for less than a watt of power, for like a few hundred milliwatts of power for applications like sensors and hearing aids. At the rightmost, we have a solution for up to 300 watts of power. Mm-hmm. So that's a lot of power for wireless power. These are for applications like robotic mowers and drones and other applications like that. And I do want to mention that in the middle, there are a few Qi-based solutions that we have, and this aligns with the most recent release specification, the Qi 1.3 that was released in middle of last year. So I do want to mention that Microchip has a lot of deep expertise in authentication, which is required for Qi 1.3, and in fact we were really driving the specification in the standards body.
Okay, so let's talk more about Qi and the authentication. What's the latest development with the Qi standard?
So yeah, we have a couple of reference designs that I just wanted to touch upon. So there are two reference designs. One at the top is basically the DSP33 based Qi transmitter design, and at the bottom there is the SAMD based Qi transmitter reference design. So both are very different. I do want to clearly highlight the difference here. Okay. The DSP33 based reference design is very highly flexible design. It's really based on the DSP, of course, and the DSP has a DSP core and high resolution PWMs and high speed ADCs and high speed comparators that enables a really efficient wireless power implementation. Mm-hmm. So for example, the demodulation that is done is all done with the DSP core and using some digital filters and the high-speed ADCs. So you don't need any external additional BOM, so minimizes total BOM cost. So okay. It's a very flexible design, and also customers can really build on top of what we offer. If they have any custom features that they would like to implement, we seamlessly enable that. So at the bottom is the SAMD-based design that I mentioned. It's a production-ready module. So basically, you can take the design as is and implement it in your automotive environment finally. So you can just take it and you can just run with it. It's a really production-ready module. So you can clearly see the difference between the two designs. One is like a reference design, which is flexible, and other is really a production-ready module.
Okay, so with the reference design, it's hardware and software, but you can adjust and adapt. And with the module, it's hardware and software also, but everything's fixed.
Exactly.
Okay, very good. All right, so we're talking about standards. So let's talk automotive a little bit now. So I'm excited about getting wireless power in a car because as we've all been driving somewhere, we want to keep our phone charged. We don't want that extra cable to get wrapped around our coffee cup. Yeah. So now we can have wireless power in the automobile. But when we talk about the automotive environment, we need to talk about AEC qualification, and increasingly we want to talk about functional safety. So can you tell us what's going on in wireless power in these areas?
Sure, yeah. So AEC Q100 qualification is mandatory really for our controllers for automotive chargers. And really Microchip has a lot of expertise with AEC Q100 qualifications. And in fact, some of our controllers are qualified up to level of grade 1 and even grade 0. So we have really a lot of expertise with Q100 qualification. And even some of our other components on our system, on our reference design, are all Q100 qualified, of course. And moving to functional safety has become an interesting area from a wireless charging implementation standpoint because of the foreign object detection feature in particular. So from a functional safety standpoint, functional safety is not just adding like a hardware feature or a software feature, but it requires an entire development flow to adhere to the safety specification.
Right. Okay.
So we at Microchip provide the entire ecosystem for customers really to speed up the development and certification process.
Okay.
So for example, for our controllers, we provide the things like the certified safety manuals, the certified FMEDAs, and also the certified diagnostic libraries. And in addition, our MP Lab development ecosystem is fully aligned with the safety process as well.
Okay.
So I do want to mention that our most recently released DSPIC is really ASIL B compliant safety element out of context.
Okay. So we're talking about the development system, which is fairly complex. Can you walk us through what that environment looks like?
Sure, I want to touch upon the AutoSAR as well. Really, the AutoSAR is also becoming an important feature for high-end wireless chargers for integration into the automotive environment, of course. And then recently we made an announcement that our wireless charging controllers fully support things like the AutoSAR BSW from Vector and the AutoSAR OS from KPIT. And in addition also, we provide the full set of MCAL drivers, which are both ASPICE level 1 and ASIL B compliant. So we provide a full ecosystem for our devices to integrate seamlessly into the automotive environment. Of course, in addition, we also have the crypto device, the libraries of which can easily integrate into the AutoSAR environment as well.
Okay. And how would somebody get access to the AutoSAR package?
So it's a good question. Please reach out to your Microchip sales representative, and once you sign an NDA, we'll provide all information required as to how you can access this.
Okay. Okay, great. So we've talked a lot about the transmitter side. Let's talk about the receiver side and the options available there.
Sure, yeah. So just want to touch upon a couple of receivers here. We have a Qi 1.3 prototype receiver, and this really helps our customer to do some prototyping with Qi 1.3 transmitter. And essentially this receiver can send a challenge request, and you can validate the response of the transmitter. So in addition to just the Qi 1.3 implementation, also the somewhat of a flexible design that this is, it enables increasing the power levels to beyond 15 watts that the Qi 1.3 specification supports. And also you can add additional algorithms if you have any battery charging algorithms or anything like that, that can be added on to the controller as well.
Okay.
And below that, I wanted to touch upon, we have a little bit more of a cost optimized Qi 1.2 design. This is supporting the Qi 1.2 standard, but this is really a cost optimized design which includes some battery charging algorithms as well, and can charge a simple lithium ion cell and can implement features, or can implement it can really work well in applications like a VR headset and things like that, which are becoming popular right now.
Okay. All right, so on to the high power stuff. If we need more power than these Qi designs, what do we have?
Sure, yeah. So this is certainly an interesting design. I'd like to talk about this for a minute here. And this is a unique design, if I would say, in a sense, because this is really a design based on some fixed function controllers that we've developed. This includes some proprietary wireless power IP as well, and this supports a pretty wide operating input voltage range, from the range of about 11 volts to about 36 volts. And of course, efficiency is key. This has very high efficient implementation, and the most critical aspect for high power or for wireless power in general is foreign object detection, and this becomes more important really at higher power.
Sure.
From a safety standpoint and things like that. So this solution implements a very reliable foreign object detection scheme.
Okay.
So while there are some real benefits that you can with this solution, obviously there are some challenges. This is a little bit different from the 15-watt solution that I talked about earlier, because 15-watt solution is a little bit better understood. This is in this solution, in this 300-watt solution, the voltages and the current levels are a lot higher, and there are some challenges that really need to be addressed. Also, with custom coils here, there are a lot of coil-to-coil parameter variations in a production environment, which can really impact things. For the coil-to-coil variation, the FOD performance, then tuning gets impacted because of the variations. And of course, things like the efficiency, EMI performance, and all of those things have to be really well maintained in a design like this. And we really have all the tools needed. We have done a lot of extensive development with this. So we have a lot of design guidelines, a lot of lessons learned, and we provide a lot of information related to coil calibration and all of that, and can really seamlessly help a customer take a design from concept all the way to released product.
Awesome, awesome. Well, a fascinating set of reference designs and material. There's a lot going on here. So there's hardware, software, tools, there's transmit side, receive side, there's a range of power levels. Do we have a place people can go to get more information about all of this?
Yeah, definitely, yes. So this website, www.microchip.com/wireless-power, has a lot of the information related to what I talked about today. And yeah, please feel free to reach out to your Microchip representative, and we'll be very happy to help you with some of your wireless power solution needs.
Awesome. Awesome. All right. Well, thanks, Vijay, for sharing your expertise with us today. At this point, let's transfer over to Aaliyah in the booth. Aaliyah, do we have questions from the live audience today?
Yeah, we do have a few questions that we received via email. So how do we get a sample of the DS-PIC33 Qi 1.3 transmitter?
That's a good question, and that's a pretty hot topic right now as well. So that's a good question. So we worked in partnership with Avid, who's a subsidiary of Avnet, and made this reference design available. So you can reach out to your Microchip sales representative or an Avid Avnet sales representative, and just request for a Microchip MPA13 Qi transmitter.
And I do have another one from YouTube. Is long-range wireless power possible in the future? For example, getting in a car, a phone automatically starts charging from a 5 feet range, or laying in bed and the charger is on a nightstand.
Oh, that's an interesting question. There has been a lot of talk in the industry about long-range wireless power, and it works for certain applications. So for example, for very low power applications, for like sensors and things like that, where you're only charging, where you're only powering with roughly about a few hundred milliwatts. Mm-hmm. Those kinds of power ranges are kind of okay for maybe several inches, but really not charging a phone. I mean, charging a phone takes a lot of power, and I think it's going to take a long time before a lot of things like FCC regulations and all of that are met for long-range wireless power. Mm-hmm. But I mean, that's the holy grail, but there's a lot of technical challenges to address before we get there.
Yeah.
And what kind of support does Microchip provide for the 300-watt wireless power implementation?
That's a good question. So for a 300 watt solution, because it's a challenging design, there are a lot of design guidelines we provide. So once you sign an NDA, we provide a lot of design collateral, things like schematics, BOMs, and also detailed layout guidelines. In fact, we can also provide board design files, and we can provide all of this information, and we can do some schematic and design reviews with you all, and then really help the if I would say first pass success of a design.
And I have another question that we received from LinkedIn. What parts limit efficiency?
So that's a good question again. So things like efficiency, things like the parameters in the coil, the DC resistance of the coil, and things like the switching frequency and the tuning between the transmitter and receiver coil. So those are some of the key points. And other things also things like the RDS on of some of the FETs in the switching circuits, and all of those as well affect the overall efficiency. So it's a very tuned system, if I would say, and tuning the system optimally really optimizes the efficiency, and that's why some of the challenges in wireless power kind of need to be overcome and kind of understood, and really kind of supported.
Yep. Okay.
And is there going to be a wireless charging solution for laptops anytime soon?
So that's a good question again. There is some activity for standards development for laptops as well. So this is roughly in the range of about 45 watts to 60 watts, but it will be interesting to see how soon specification is released and we see products in the market.
Yeah.
And it looks like we have one more question for you. And are there any security concerns related to wireless charging?
Yeah, so yeah, like I talked about with Qi 1.3, security is really a very critical part for Qi 1.3, and really it's a very complex process to manage all the provisioning and getting all of the software integrated and managing the entire ecosystem. So Microchip is really a manufacturing certificate authority. So really what that is we have full responsibility from a provisioning standpoint, and really we could help our customers through the entire process, which is a bit of a challenge for people who are somewhat new to this field, but because of all the expertise we have, we can really guide you through the entire process and make your development process headache free, if I would say.
All right, well, it looks like I have one more, so this is going to be the last one. Okay. Is high power wireless transmission possible?
Yeah, so we touched upon about 100 to 200 watt wireless power. So that is, if I would say, I mean, even we can consider that to be high power compared to the cell phone charging, which are in the range of 5 to 15 watts. But there's also some development activities for wireless power for electric vehicles. Yeah, that's definitely some work going on there. There are some standards bodies there as well, and that's going to happen in the future. But again, it will be interesting to see how soon that happens.
Sure.
So those are all the questions I have for you today. Thanks, Eric. Thanks, Vijay. And again, you can always email us at livestream@microchip.com if we miss your questions and comments. And don't forget to follow, like, and subscribe to all our social media platforms. Thanks, guys. Back to you.
All right. Thanks again, Aaliyah. Thanks again, Vijay. And most importantly, thank you to our audience for taking some time out of your day to join us for Coffee Break today. For more information, visit microchip.com/coffee break. There you can see information about our whole series. You can sign up for notifications. You can add specific future events to your calendar and keep up to date with all of the Coffee Break episodes. So again, thank you for your time. Hope to see you next time. Good day.